Great. I'm CJ Newburn, and for the compute software part of NVIDIA, I kind of drive what we do for strategy and roadmap, key customer engagements for HPC. And one of the things that we do is to work very closely with partners like SUSE, and I'll talk today about a number of the things that we've been working on, collaborating together, and where we're headed in the future to help you as end customers. So, how many of you are familiar with using containers? Used containers before? Right, that's 2 out of 4, 1.5, 2 out of 4. All right, great. So I'm going to talk a little bit about what containers are good for, why they matter to HPC, and some of the things that we're doing in this space. And I'll do some forward-looking things for where we're headed with this. So the first thing is, if you look down at this diagram that's on the right-hand side, we work a lot to try to innovate what we do inside the hardware to be able to deliver value to you folks, being able to accelerate things. But acceleration happens in concert with the rest of what's happening in the rest of the system. So we work closely with other peripherals for I/O, for storage, so in addition to just being able to put something in the system, because a lot of others could create something else that has lots of computational power, the real value comes in what's stacked on top of it. So the thing that goes above that is essentially our software platform, CUDA, and along with that is a whole ecosystem. We spent more than 10 years sort of building up trust with our different customers, enabling on the order of 550 or more applications to make best use of our platforms, enabling third-party frameworks like PyTorch, TensorFlow, whatever on top of this. The challenge, though, there is, how many of you are developers? Okay, so Srinivas, if you had put your heart and soul into developing a really great application, you would really like people to be able to use the latest and greatest, right? And to be able to get the best performance. So if somebody has some aspect of their platform that's not your application's fault, that's suboptimal and that's not tuned because they didn't have the right things installed and they weren't using the latest version, that would disappoint you because they're not getting your best. How many people are sort of administrators? Right? So you probably have a long list of people that come and say, hey, please install this, please get the latest version of this set up for me. And you're kind of like, yeah, take a number, right? Because there's so many people that are lined up for this. Because it can take, I'm sure you're brilliant and this would never happen to you, but we've had brilliant people that take some of these HPC apps and it'll take them 2 or 3 long days just to be able to get it to build and go together, right? That's hard. So if you can take all of that complexity, all those dependencies, and wrap them inside a container and just say, whoop, here it is, so that all you really need to do is click a button, say what it is you want to download it and run it, that's a whole lot easier and brings greater value to everybody. So essentially, taking all the ingredients and combining them in a pre-validated way so that you're confident that those things will work together and be able to, many people are still running various different kinds of operating systems. And so if something was written for an Ubuntu OS, an interface, but it has the same kernel as what you have on the CentOS system, you're golden, right? You can just take it and run it that way. You also want to be able to isolate and carefully manage the resources behind this. So containers and orchestration being kind of the scheduling and management part of this, is kind of the key way to deliver this overall package of value that we have. Welcome. So essentially the way it does that is to curate the runtime environment. So Srinivas, I don't know how complicated your system is, but you have environment variables that you need to be able to configure and run your thing properly, right? So you can have a README that tells somebody that somebody has to read through and figure out. And how often do you experience that people never read the README and then they complain that it doesn't work right? Yeah, exactly. So if you can essentially deploy something that has a best practices environment that's already set up, they can override it. That takes you a long ways. Or some people want to be able to compress files or use certain customized run times and so on to be able to get best performance for this. And as you're downloading, if you're, as I'll mention before, if you're not careful, Many of these container images can be like a gigabyte or more. And being able to manage carefully how you put those together and build those and manage the layers can bring you down to where you're more on the order of 100 megabytes with these. And that's a key part of goodness. So these are some things that containers are good for. The next question is, why does HPC matter? So we at NVIDIA really believe in essentially democratizing HPC. We think that there are a lot of you who are experts who really know how to do HPC. Your abilities and talents are wasted if a lot of the other people who don't know much more how to then push a button can get access to all the gifts and talents that you have to share, right? So we're trying to, you may have scientists who may be brilliant people, but that don't really care to learn anything about computers if they can help it. So making it easier to develop, to deploy, and use these is a key thing. So if you look across all of the different kinds of application domains, you could say, well, HPC, that's only sort of a small fraction of all software and applications that are out there. But if you look at HPC as the thing which manages high performance and which manages scale, then it's not just sort of this narrow band of geeky scientists that are using it, but it's a much broader set of the Walmarts and many other companies that are wanting to do basic consumer data mining, artificial intelligence, and those kinds of things. And there are a huge number of people that are entering into this space, but they want to be able to do it. So by making it easier to deploy, they could look at a GPU and say, whoa, I can barely run a computer, much less a GPU. If you can contain that, so to speak, and make that easier for them to use, that's good for them. And if you can make sure that they get the right ingredients, that the right software elements are there already, and you can easily compose those across different kinds of applications, that's all a win for them. So these are some of the things that make HPC relevant in this space. So some things that NVIDIA is doing. We are working with developers to be able to tune and scale the performance that we have with these things. We also take developers' applications and we validate them. We run them on our own cluster, make sure that they work. And if we put something up there for you to be able to download from our registry, you can have confidence that it's actually going to work for you. Okay? And we want to stand behind that. If there's a bug, we want to go and understand what was the issue, right? So that might be if it's really just an application bug, then you talk to the application manager. But we want to make sure that it works and interacts with the system properly. So we're finding that that's used by an increasing number of data centers. Georgia Tech is one of them. So we essentially want to make this easy and robust. One of the tools that we've created to this end is something called HPC Container Maker. So if you think of like going into a Chinese restaurant and you say, well, I want to be able to use OpenMPI. So you write basically a very short Python script that says, start with this base container and then plus equals OpenMPI. Well, what version do you want? You can take the default version, or you can say 3.0.1. And you can say, I want it to be compiled so that it runs with the SORM schedule. You can say, what network driver do you want? Oh, I want MoFed 4.4. And it'll find those things, and it'll bring them together for you, and it'll build the container up and layer it appropriately so that it can be compact. I'll talk a little bit more about that as well. So this is a way, it's an open source thing that we posted up on GitHub. We found that a lot of people are using and adopting this, and we've been very responsive in adding additional kinds of features to that, different ingredients that we want to support for this. Another thing we're doing is moving the broader HPC community forward. I'll talk a little bit about that. We're certainly floating lots of boats in doing enabling with different kinds of container runtimes and orchestration infrastructure. We're also working to identify and address some of the technical challenges in the community. I'll talk about that. So this is some fun eye candy for some different areas that we're doing some work in. And if you look at the list, these are the things that we currently have posted up in the NGC registry. Those that are in green are ones that have gone up just in the last few months. Those with the little star behind them are those that are now multi-node container. So how many of you care about running applications on multiple nodes? Okay, yeah. And that was a little tricky getting started, and we're making that easier and easier as we go along. So we have quite a number of these containers that are out here, and that's growing over time. That includes a lot of the top things that people are interested in using. We have a lot of people, it is a Docker registry, but you can take the Docker images and run them just fine under Singularity. And so there are people that were scared about that. We did a little blog and say, oh, really, it's not bad, it's not a problem. And there are a number of different data centers that are using these things. So we have a notion of what's NGC Ready. And with NGC Ready, we basically work with OEMs and other partners to say, hey, we know that something that's built in this way with these platforms are ready to go. You can just take one of these things and download it, and the right software and the right configurations are there to be able to make best use of this. So let's look again at, since a number of people said they were interested in multinode, these are some of the different trends and characteristics that we see. People need to use a shared file system. They need to use more advanced networks. They want to use GPUs, often MPI. They're using different container runtimes, trying to do some resource management. They have various different ways they want to do parallel launch, and they're concerned about size. So these are the kinds of things that we've already taken and validated in the containers that we have to make sure that they work with you. And then we post those as READMEs along with each of the registry entries to be able to do that. And here's an example of where LAMPs, we got compiled down to, or compressed down to just 100 megabytes. And that's a careful process of essentially, as you build each step, figure out any other cruft that doesn't finally need to go in there and leave it behind, whether that's a multi-stage build or just removing whatever you don't want out of it. Okay? Most of those are churning up under 300 megabytes. So another specific example, as a preferred layering, a lot of people use OpenMPI and want to be able to share memory across different processes and different MPI ranks. People may be using OFED, but we can do that, and that works fine. For these cases in our multi-node containers, we'll look for a MOFED 4.4 or later, and then we can use some of the accelerated or CUDA-aware MPI that's under there as delivered through UCX. So those are some developments. So we just got out of a BOF not so long ago, and we have another sort of part 2 of this that's coming up at 5:15. I think that's in 167, I'm not sure. So we have an advisory council that includes SUSE, several people from SUSE, and essentially what we're trying to do there is to identify what are the hardest problems and technical challenges that people care about. How can we drive those home, get collaboration among a bunch of people to be able to ground out on those and deliver technical solutions back to the community. It's a very data-driven thing, so there are a number of vendors that are sort of competing with each other that are on this council and enjoying the conversations we have, that we've ended up having very good and positive and productive interaction out of that to sort of drive to ground truth, including things like, hey, I think there might be a security issue here. Let's go and write tests that we can run across these different runtimes to identify exactly what those key problems are, so we can see sort of in a very data-driven and objective way what the issues are, and then the broader community can go and look at those. So if that's the kind of thing that you're interested in contributing to, we'd love to have you be part of that. So these are some of the areas of interest that we've been tackling just recently. So again, this HPC is another thing that you can get. I'm happy to leave these slides behind, and you can go and download that. So one of the other things that we're kind of exploring with SUSE, with Roger and others, is that we ourselves are looking at what are all the different software components that it takes to be able to get the best experience, most robust, highest performance, and best enabled on the platform. We want to take that, form that as a list, and share that with our partners. Then we want to say, for you as users, you can put the best thing that you possibly could inside a container, but the container is essentially for what happens in user space. If you need something to be down there in kernel space that's on the platform, and you go to run and oops, it's not there, you're out of luck, right? You at least may not get the best performance, and you may not be able to run at all. So the mechanisms that are currently available for having a container say, hey, here's what I need, here's a complete manifest of dependencies, there's no kind of standard or best practice for that. And the ability to say, hey, I know that I work with a given distro that has this version, or this certification, or this flavor, the strawberry flavor, whatever that I need for my GPUs. If such a thing existed, it would be easy for people to say, I can know with confidence that I can deploy this at any place that supports the strawberry flavor, right? So this is something we want to look with and work with partners like SUSE to ask the question, how can we work out essentially this list of software components? How can we make that part of what is easy to distribute, even if those are proprietary components and aren't open source and distributed from them? How do we make that as easy as possible for people to be able to find and leverage on their platform? So this is something we're exploring, and we also want to make that robust so that we can get sort of pre-validated combinations of those things. So this is forward-looking. This is what we think should happen on the behalf of the community, because we're looking out for the community's interests. So just to summarize, we're seeing that there's a really remarkable momentum in the area of containers. There are a lot more people that are using them, containerizing their apps, containering whole infrastructure, tool chains, all kinds of cool things. And we see that sort of moving forward from simple cases of single node containers to being much richer cases that are more complicated. And so we want to make it easy for us all to enable those best practices. And we encourage you to go to the NVIDIA GPU cloud with Docker and get Docker and use Singularity and other things, and to containerize the apps that you have and put them up there so that we can use those. And invite you to join us if you're interested in making technical contributions to what we're doing with this other effort with the advisory council. So thank you very much for your time.
All right, let's give it up for CJ.